Hi, I'm Wenzhe from Stony Brook University. Next, I'll share our research with you. JustCorrect, intelligent post-hoc text correction technique on smartphone. Correcting error is an important task in the input process on smartphones. Intelligent methods such as autocorrection and autocompletion can help users when entering text. However, it is difficult to perform post-hoc text correction, which is correcting errors in the entered text. The existing post-hoc text correction technique is cursor-based, which requires precise keyword positioning. Such a task is difficult on cell phones because of imprecise finger input. This project, we invent an intelligent text correction technique called JustCorrect to avoid character control operations. JustCorrect supports both substitutions and insertion. We allow the user to replace or insert words in the current sentence without moving the cursor. For example, if the user wants to replace JMO with jumps, she taps jumps without moving the cursor and click the editing button. The post-hoc correction algorithm will automatically replace JMO with jumps. Also, if the user wants to insert brown between quick and fox, she taps brown. The post-hoc correction algorithm will insert brown at the correct location. Below the top suggestion, JustCorrect also suggests the other two possible corrections. The user can pick the suggestion in case the top suggestion is not the intended one. Next, I'll show how the post-hoc text correction algorithm works. After receiving the input word, the algorithm will generate substitution and insertion candidates by replacing each word or space in the sentence with the input word. Then it calculates the scores of the candidates from the three channels. The editing distance channel estimates the editing similarity. The word embedding channel estimates the semantic and syntactic similarity. And the sentence score channels calculates the probability of the sentence. The algorithm infers the user's correction intention by combining the scores of the three channels. First, it sorts the substitution candidates by the substitution scores and sorts the insertion candidates by insertion scores. Then we compare the log language model probability of the first substitution candidates and the first insertion candidates. The greater one is used as the first suggestion, and the smaller one is used as a second suggestion. In this way, the top two suggestions contains both substitution and insertion candidates. We're doing the same thing to solve the third suggestion based on the second candidate pairs. We conducted a controlled experiment to evaluate JustCorrect keyboard in a post-hoc text correction task. The first study compares JustCorrect keyboard with the stock Android keyboard with cursor-based method, and the second study compared JustCorrect keyboards with recently published Type Then Correct. In JustCorrect method, the user can correct the error by clicking the editing button. In the Android keyboard, the user was allowed to correct the sentence by the cursor-based method. In the tap then click method, the user can press and throw the word toward the position or just click the smart button. The user studies showed that JustCorrect reduced the post-hoc text correction time in both studies. The difference was statistically significant. The subjective scores also showed that the user preferred to use JustCorrect comparing with other two methods. The difference is also statistically significant. In this paper, we designed the post-hoc autocorrection algorithm, which infers the user's correction intention based on the entered word and makes the correction. JustCorrect also complements the existing text correction method and significantly enhance the text editing performance for the users. Please see the paper for more details. Thank you.